Hello and welcome back. This is Mr. Laiche with Portland Math Tutor. Today we are going to be working on solving quadratic equations using the quadratic formula. Now, when we say solving a quadratic equation, what we're referring to is figuring out where or what x value is going to give us an x-intercept. Okay? For example, we might have a parabola that represents a quadratic equation that touches the x-axis in one spot. Okay, well, we're going to say that this has one solution. Okay, another case that we might come across is a quadratic represented by a parabola that crosses the x-axis in two spots, and you probably guessed that's going to have two solutions. Okay, and then finally we might have a parabola that doesn't cross the x-axis, and we're going to say that that has no real solutions, because we know that every polynomial of degree 2, which is a quadratic, is going to have two solutions. Now, those solutions could be imaginary or they could be real. Okay, so what we have here in this last example is no real solutions, while it will still have two complex solutions or solutions involving imaginary numbers. Okay, so the easiest way to solve a quadratic is going to be to factor. Okay, you can watch some of the other videos to study up on how to factor quadratics, but you're going to find that there are some quadratics that are very difficult or just impossible to factor. So luckily we have a tool at our disposal to deal with that kind of situation, and that is the quadratic formula. Okay, you can watch another video of how to derive the quadratic formula to figure out where it comes from, but this video we're going to focus on its application. So let's get started. Okay, steps to solve quadratics using the quadratic formula. Step 1 is going to be to write our quadratic, or write the equation in standard form. Okay, in standard form, a little reminder here, is ax squared plus bx plus c equals 0. Essentially, you're just getting all of your terms to one side and setting the equation equal to 0. So what we're doing here is we're setting the equation up so that our output is equal to 0. That's exactly what we want. If you recall, when we're solving a quadratic, we're trying to figure out where it crosses the x-axis, and where it crosses the x-axis, the output is 0. So essentially what we're saying is where is the y value equal to 0. All right, step number 2. Number 2 is we are going to identify A, B, and C. So we're just going to write out A equals, B equals, and C equals. Okay? And that's going to be different for each quadratic, depending on what these coefficients are and what the constant is at the end. Okay? So that's step number 2. Step number 3, let's see, step number 3 is going to be to substitute the variables back into the formula. Substitute the values into the formula. Okay? And if we can squeeze this in here, we're going to have one last step. And that's just going to be to simplify the formula. Simplify or perform order of operations. Order of operations. Squeeze in there. So now if you want to pause the video, you can write down these steps. I'm going to change the page and we're going to go over some examples so you can put these steps into practice and see how it all comes together. All right, here is our first example. So the first step, step number 1, was to write the quadratic in standard form. As you can see, that's already been done for us, so check that box. Step number 2 is to identify A, B, and C. And what we're going to do here is we're going to, here, let's write it out. A equals, B equals, and C equals. So we go back to our equation, and we see that A is the coefficient on x squared, and that's going to be a 1. We know that it's a 1. We typically don't write a 1 as a coefficient because it's redundant. Looking at B, B is the coefficient of the linear term, and that would be -8 in this case. Remember to take that negative with the coefficient. And then finally C. Well, C is going to be the constant term, and in this case the constant term is 14. All right, moving right along. Step number 3. Step number 3 was to substitute our values into the formula. The formula, let's see, I've got a copy of it right here. Squeeze that and put that up in the corner just to have it for reference. Now, as we're substituting into the formula, if we have any negative numbers, it's always a good idea to put those negative numbers in parentheses. Okay? So all we're doing is substituting A, B, and C. The x value is the value that we're trying to solve for. So we have x equals negative b. Well, b is -8, so I'm going to put that in parentheses, plus minus the square root of b squared, it's -8 in parentheses again, minus 4 times a, which is 1, and times c, which is 14. All under the square root, on top of 2 times a, which is 1. Okay, so we've substituted our values into the formula, and now we are going to go on to step number 4. Step number 4 is just simplifying the formula or performing the order of operations. I am going to copy this to another page, so I've got a little bit more room. There we go. Order of operations. My first step is going to be to we'll deal with this piece, and this piece right over here. Okay. The first, this negative of -8. Well, that's just going to simplify to a positive 8, plus or minus. -8 squared is 64, positive 64. And then we have -4 times 1 times 14. Well, let's see, that's going to be a negative. And 4 times 1 is 4. 4 times 14. We have 4 times 10 is 40. 4 times 4 is 16, so 40 plus 16, it's going to be 56. Okay, and then on bottom we have 2 times 1 is just 2. Alright, moving right along, I'm going to simplify the square root now. 64 minus 56, well, that's just 8, I believe, yeah, 8, and divided by 2. Okay, now we can simplify this square root. Okay, so we're looking for perfect squares that we can pull out. So perfect squares are 4, 9, 16, 25, 36, and so on. Let's see. 8 can be written as the product of 4 times 2. Okay. All right. Perfect. Well, now that we have that splitting up into the product of 2 factors, we can take the square root of the first factor, and what we'll have is 8 plus minus square root of 4 is 2, and we still have the square root of 2 left over, all over 2. I'm just going to slide this over here. Give myself a little bit of room. Actually, I'm going to pull this up here. So I can see that both of my terms in the numerator can be divided by 2. So I could simplify this to a 4 plus minus the square root of 2. Okay, so this is going to be actually 2 solutions. One where x equals 4 plus the square root of 2, and one where x equals 4 minus the square root of 2. Okay, and then you can plug that into your calculator to get a decimal approximation. But this will give you a pretty good idea of where the x-intercepts are going to be located. Okay, here we go for another example of using the quadratic formula. This example, we're going to have negative 3x squared plus 6x equals negative 5. Okay, so if we recall, the first step was to write our quadratic in standard form. So we need to set it equal to 0. To set it equal to 0, we're going to need to add 5 to both sides. And we are going to get negative 3x squared plus 6x plus 5 equals 0. Okay. Our next step is to identify A, B, and C. So those values are A, B, and C. So A, remember, is the coefficient on the squared term. That's going to be negative 3. B is the coefficient on the linear term. That is going to be positive 6. And actually that, I guess you could say that positive goes with it, a plus goes with it. That determines whether it's a positive or negative coefficient. So anyways, moving on. C. C is going to be the constant in this equation, which is positive 5. Okay, so we've got our A, B, and C. Now we are going to substitute them into our equation. Just going to keep this formula up here in the corner, just keep it in mind. So we've got x equals, well, what is b? B is 6, so negative 6 plus minus the square root of b squared, so 6 squared minus 4 times a, which is negative 3, times c, which is 5, all over 2 times a, which is negative 3. Okay, so now we're going to go in and simplify. We're going to get x equals negative 6 plus minus the square root. Well, 6 squared, that's 36. And then we have negative 4 times negative 3 times 5. Oops, times 5. Well, negative 4 times negative 3 is positive 12. Positive 12 times 5 is 60. Okay. And then on bottom we have negative 6. Okay. We have x equals negative 6 plus or minus the square root of 36 plus 60. It's 96 over negative 6. Okay. See if I can squeeze it in on this page. So I'm going to try and simplify this radical so that we can break it up a little bit, simplify this expression. We're going to get x equals negative 6 plus or minus, let's see, square root. What perfect squares go into 96? 4? Yeah, sure, 4 goes in. 4 goes in to 80 20 times, and then it goes into 16 4 times, so it'll be 4 times 24. 9 doesn't go into 96, but I can see that 16 goes into 96. 16 goes in 6 times. 6 times 16 equals 96, divided by negative 6. Okay. Well, that's going to simplify. We can take the square root of 16. That's going to be 4, and be left with the square root of 6. Okay. At this point, I can see that I can divide each term in the numerator by 2, and I can divide the denominator by 2. So that's what I'm going to do. I'm going to get x equals, it's going to be negative 3 plus minus 2 square root of 6 over negative 3. Okay. I generally like to get rid of those negatives. If we multiply the top by negative 1 and the bottom by negative 1, we're just going to end up with x equals 3 plus minus 2 square root of 6 over 3. Okay, and there is our solution. Of course, that's going to break up into two solutions. It's going to be x equals 3 plus 2 root 6 over 3, and x equals 3 minus 2 root 6 over 3. Okay, so that concludes our video on applying the quadratic formula. In the future, I would probably anticipate doing some more example videos, so take a look for those.